Welcome to the fourth colloquium on public interest technology. This one is dedicated to COVID responses, innovations and public interests. It's great to be with you again. We're from the School for the Future of Innovation in Society at Arizona State University. It's also brought to you by the Society Policy Engineering Collective, a group that I direct here at ASU. And for a short time, these colloquiums will be broadcast at our International Symposium on Technology and Society, the annual IEEE ISTAS event. Today, we have a wonderful speaker lineup, but first I'd like to introduce Elisa Graffy, who's chairing this colloquium today. Elisa joined ASU as a professor of practice in 2012, and she's also a senior sustainability scientist at the Global Institute of Sustainability, and co-leads the policy theme for ASU Lightworks. What I find particularly amazing about Elisa is that she spent 2 decades at the Office of Technology Assessment at that US federal level. And she specializes in science policy and its interface, public engagement, and also strategic management. Her PhD is in environmental science, with an emphasis on public policy. But when I read about her work and her contributions to academia and practice, I'm just taken aback. She wrote a foundational paper in the Public Administration Review some years ago, which won acclaimed awards, for instance, in 2008. And she was honored with the Brownlow Award for the best article by a practitioner. And what's amazing is that we have Elisa teaching into the Public Interest Technology program here at ASU, our latest Master of Science and online degree. So with that, I'll pass on to Elisa now, and she can introduce the rest of the colloquium.
Thanks, Kat. I am really pleased to be having this discussion. This is a seminar that those of us on this panel have been discussing in various ways all summer, and have been quite eager to have this discussion. And having it in the context of public interest technology instead of in the context of pandemic response alone adds an extra layer of complexity to this discussion and some additional issues that are going to, I think, give a somewhat different spin to a conversation or a set of issues that all of us may feel that we've heard quite a lot about, and all it does is get more confusing and more complex. In order to cover this from the various facets that really do add some light, some illumination to the issues, we have with us Bob Cook-Deegan, who's a professor at SFIS, who will be speaking about medical innovations and the way those impact public responses to COVID. Kevin Dooley, who's a professor in the business school at ASU, is also a supply chain expert and a sustainable business expert. Anna Muldoon is a PhD candidate in our school. She is also part of the COVID modeling team at ASU. So she's been doing a lot of the kind of analysis that you hear about in the news all the time about whether the virus trends are going up or down, and positivity rates and all that sort of thing. As each person comes into the conversation, I'm going to ask everyone to talk a little bit about yourselves and explain why you're interested in COVID at all, because this is not an issue that most of us were thinking much about before about 6 months ago. And I think that that will also give a certain sort of good lens to the idea that this issue is something that applies to everyone, that has a number of elements, and that we can actually understand them in an integrated way. So one of the things that I want to, you know what, there's my technology issue. So there are the shots of Kevin and Bob and Anna. I want to talk to you a little bit about why we are putting this particular combination of words together. Why are we talking about innovation and public responses with regard to the pandemic? So for one thing, let's define some terms. Innovation means to do whatever it is in a new way. And in this particular case, with regard to this pandemic that's widely described as being unprecedented and complex and having lots of intricacies that we're still only discovering, there have been a number of elements in the public response to the pandemic, to managing the pandemic. There have been crisis management innovations in the public realm, in the governmental realm, in the medical discovery, implementation, service delivery realm, in terms of the economics, in terms of understanding the impact on the economy, in terms of developing new ways of trying to carry out economic activities when we can't be in close contact the way we traditionally are. There have been innovations in scientific investigation and assessment. So beyond the kinds of modeling that Anna's going to be talking about, there's also been a lot of a ramp up in scientific investigations about things like masks and materials and how to understand the mutations in the virus itself and a whole range of things. There's a whole area developing in indoor air quality focused on mitigation and adaptation. Civic engagement is something that we'll touch on a little bit here because it is on the one hand part of any kind of public response to any kind of crisis. But on the other hand, it's particularly interesting in the case of the coronavirus because civic engagement has popped up in a variety of unexpected ways to some degree to deal with some of the unprecedented nature of this particular crisis and also sometimes to compensate for what are viewed as gaps in the responses in other areas. So here's another thing that we want to talk about. When we talk about public interest in the term public interest technology, there's a tendency to think that it means a particular thing, that it always means that we're looking for fairness and equity and inclusiveness. The thing is that public interests are studied by a lot of social sciences because there are a bunch of different kinds. There are a bunch of different ways to understand what public interest means. For our purposes today, one of the things that I want to stress is that public interests are always grounded in some conception of social ethics. And there are a lot of social ethics that people can pull from. There are a lot of philosophies about ethics. But I'll pull out a couple just to sort of give you an example. So one way of thinking about social ethics is that whatever you're doing, whatever your responses are to a crisis, the idea is to benefit the most people, the greatest number of people. Another social ethic would be that in your responses, you're trying to benefit the people that are the most privileged. So not the most, but the most privileged. Or that you're trying to focus on the people that are the most vulnerable. Or that you're trying to develop a response that's the most equitable across the board. And there are names that we associate with these different things. So a focus on responding in a way that benefits the most people is a version of utilitarianism. To focus on the most vulnerable is a social justice ethic. To focus on the most privileged there is actually a thing called power ethics. It's a Mitist ethical principle. And to focus on the most equitable arrangement is an egalitarian one. So these are not just philosophies. These philosophies of social ethics, they underlie governance systems. They underlie the kinds of governments that we create. Let me move this out of my way so I can see. When we talk about things like monarchy or plutocracy, oligarchy, democracy, autocracy, these are governmental systems that are each rooted in assumptions about which kinds of social ethics we are caring the most about, which social ethics we want to institutionalize and operationalize in how we do things. So rather than be airy-fairy or vague or sort of abstract, social ethics are the foundation of pretty much everything we do. Social ethics turn into the institutional arrangements of governance. What does that mean? It's another kind of abstract sounding word, but it translates into the rules, the laws, the way economies work, what counts as a crime, what the government looks like, how we define safety, what the jurisdictional responsibilities are across different levels of government, and significantly, it determines what we think is valuable enough that we invest our public resources into achieving them. So in this particular case, I'm just going to make an assertion. I'm going to assert that in the United States, we believe that democracy is the governance structure that we're operating from, and that the social ethics that underlie that are that we're trying to benefit the most people in the most equitable way. That's what we think of as going along with the form of government that we have. Now, if we're doing that, then our public responses would have a few different goals. One would be to build social cohesion. Another is to support social stability. Another is to promote public safety, public well-being, economic stability, and security. Now, there's a lot in the news. There have been a lot of analyses that are not yet complete about whether or not the federal response has been adequate in many regards. One of the things that's interesting and important to understand in the context of innovation and responses is that when the federal government doesn't do what the federal government normally does, which is where a lot of the criticisms have come from in terms of federal response, that is a form of innovation. Innovation doesn't always mean good. It doesn't always mean it works out. It doesn't always mean that it's better than what was done before. It just means it's done differently, that it's new. So if the federal response is focused on animating the private sector and not exercising all of the tools that the public sector has, that is or could be considered an innovation. And then it's up to us as analysts to try to figure out whether or not that has been a good innovation or not so good innovation. In our case, with regard to testing, with regard to personal protection equipment, with regard to shoring up the economy, with regard to a whole range of issues, when there are perceptions among the public that governmental action at whatever level isn't sufficient, we do tend to see a fair amount of innovation. And let me cut that down a bit. And I'm just going to mention a few of them. One has been a real surge in organizing and in sort of quasi-civic governance through social media. So through some of the apps like Twitter, Nextdoor, kind of Facebook, but Nextdoor and Twitter have been really, really interesting because they've created virtual communities sharing important information, expert citizen sort of collaborations. There have been, there's a whole sort of what I joke is the federal diaspora. People that have been federal officials who know how certain things work have taken it on as a public service to share their knowledge and understanding and being able to explain what's happening in the policy and management realm and the scientific realms. There has been a surge in public marches and protests, active public engagement with the Black Lives Matter movement and a number of other issues that have gone along with that. There's been a surge of innovation around food. One of the things that happened during the pandemic is that people lost jobs. The economy really took a hit. People have been hungry, and there have been a number of things going on from victory gardens in people's own backyards to community gardens producing food for food banks to a variety of informal arrangements where people are sharing resources, money and other kinds of food exchanges to try to fill in some of those gaps. And masks. So masks have become just an absolutely incredible symbolic and active space for civic engagement. So back in May, starting with some medical folks on the West Coast, a call started to come out. This is before masks were known to be an important thing or a big deal, asking for the public to make masks, homemade masks, because there was a shortage of PPE. This is before it was a public behavior to wear masks for protecting other people and to deal with asymptomatic infections. And people started making masks at home. People are still making masks. People are ordering masks from abroad and bringing them to neighborhoods. People are using social media to take orders from friends and neighbors and health professionals across the country to sort of fill in those gaps. This is a movement that started in May, and it's continuing. So one of the interesting things about this, there are a number of them, but a couple things I want to point out in the context of public interest technology is that masks themselves are a type of technology. And part of what's going on during this movement is that there's been this very interesting collaboration between medical experts and members of the general public. So this isn't something that members of the general public decided would be a good idea. This is something that medical experts identified as being of critical importance, even though it was not being discussed as a formal public management strategy. And members of the public who knew how to sew became engaged. So this is an expert public or an expert citizen science collaboration that's been extremely fruitful and has led to a number of positive things. Now masks are everywhere and people are selling them. Nevertheless, this civically engaged mask movement continues. One of the things that is really interesting and useful to do is take some of those things I just talked to you about, the definitions of the social ethics that are going on and how that translates into thinking about public interests, and also thinking about the goals of the responses and how some of the I'm going to say the technologically based responses that we might be undertaking satisfy them. What do they do? So it's not just masks. It's whether they're homemade masks or government issued masks or commercially sort of manufactured and sold masks. It's whether we deal with advancing PPE, all the medical protection sort of equipment that we need, using the Defense Production Act, which would not be an innovation. That's the way things are typically done during a crisis. That's where the federal government goes out and cuts through the regular market channels to make sure that materials that we need are produced. Or whether we don't do that and we instead try to use the private markets. And I'm guessing that Kevin's going to be talking about to some degree. Same thing is true with tests, whether they're tests to check on infection or whether they're tests for antibodies, whether they're federally administered, designed and administered tests or locally done. It makes a difference in terms of what the social impact will be and how well they satisfy some of those criteria that we may care about. The same may be true for how the pandemic itself is analyzed and how data are collected and reported, how modeling is done, what kinds of things are being modeled, what things do we care about. Same is true for the sort of self-protective orders that might go out, whether it's a nationwide stay-at-home order, for example, whether that's issued at the state level, at the local / city, county level, or whether it's issued at a very, very micro level, such as an office, a campus. The human behaviors that go along with them are different, and the degree to which they can foster social cohesion and stability, achieve public safety and well-being, impact economic resilience, and achieve security could be very different. Same is true about whose benefits they serve, whose interests they serve. The most people, the most privileged people, the most vulnerable, or the most equitable. And we can carry on. During the Q&A, I may come back to this slide. That's why I have this highlighted in yellow so that we can talk about some of the policies that are out there right now and perhaps go back and talk about vaccine development and think about some of the issues that are being raised there. And perhaps we can discuss how those things do or don't apply to these criteria that we've been talking about, the social cohesion, stability, public safety, and so forth. So with that, I want to pass the baton to Bob Cook-Deegan, who's going to take us a bit deeper into some of the medical issues and the health issues. And I'm going to need to continue to share this, Cindy, because this is the slide for Bob. Bob, can you unmute yourself?
I have. Can you
Excellent.
hear me now?
Oops, wait, let me go back to where I was. Yes. Okay, so Bob, as you begin, can you tell us a little bit about your background and why you've gotten interested in COVID?
Yeah, so I'm a physician who teaches science and technology policy and have for a long, long time. I spent, straight out of medical school, I came did part of my residency, and then I came to Washington and worked at this mysterious place, the same place you did, the Office of Technology Assessment, which is a think tank for the US Congress. And our job there was to channel information about science, technology, engineering, medicine, and other technical matters into a political process and keep our credibility high on both sides of that equation. And turned out it's the first time I ever loved my job. And I stayed in Washington for 20 years, and then I became an academic. And mainly I've studied intellectual property and genomics and data flow in technical systems. Particularly, I chronicled the early history of the Human Genome Project. When COVID came around, geez, it's hard to believe that it was only 9 months ago, because it seems like it was ancient history now. But when it came around, of course, it consumed all of our lives. And just to map it to this idea of public interest technology, let's take each of those words. Is it public? Yeah, it affects everybody. Do we have an interest in it? Yeah, big time. The stakes are really high. It's life and death. 200,000 Americans dead, more than 6 million people on the planet infected. And what's technology got to do with it? Well, it's the only way out of this crisis. So there are about as many bugs in our planet as there are stars in the universe. And it turns out that some of those bugs figured out, well, they didn't figure anything out. They just happened to configure themselves so they reproduce in human hosts, and they don't care where they are. They don't care anything about it. They're little pieces of DNA that spread. And it turned out that they could infect, be communicated from person to person. And when that happens, and it has happened historically over and over and over in history, there are periods in European history when 1/3 to half the population died because of a plague. And a century ago, this book, I don't know if you can switch over to, I guess nobody's watching me. I think they're just watching your screen, Elisa. But
no, we can see you, Bob. We can see you, Bob.
Oh, can you? Can you see the book? Oh, okay.
That's it.
So
beautiful.
This book is the book that our president, then George W. Bush, read when he was president, and said, you know, this is going to happen again, so we better do something about it. Let's be ready. And frankly, when a new infectious agent that is highly contagious hits a human population, the only way to effectively manage it is to be ready for it, because otherwise you're catching up. And so, golly, we did, you know. The president sent down the commands, and in fact, our government began to make plans, what could happen, develop strategic policies and technology approaches for developing vaccines and tests and protective equipment. And that carried over actually into the Obama administration. And then, like human beings do, we kind of forgot about it. And at the state level and local government level, public health has been for the last 20 years kind of incrementally defunded and weakened. And we've got a crisis. The irony here is that technology is the only way out. And our nation is the technological powerhouse of the planet. We have more biotechnology resources. We have an excellent healthcare system when it can be engaged. And we had federal agencies that are among the best in the world. The National Institutes of Health, the Centers for Disease Control and Prevention. These are places where some of the best experts in the world, highest density of expertise on the planet. And in fact, before COVID, there was a formal assessment of who's ready to handle a pandemic, and the US came out #1 among the almost 200 nations on the planet. Didn't play out that way though, did it? And the reason that it didn't has nothing to do with whether we have technical resources that are unsurpassed. It has to do with deploying those and applying them to a problem that's emerging quickly. And we'll get into that. But what we have is a situation where fully 1/4 of the cases and 1/5 of the deaths are happening in the richest nation on the planet. even though we've only got about 4% of the world's population. So what we have is a catastrophic failure of our system to deploy the technologies and the technological resources. And what we've been doing for the last 9 months is trying to catch up. And now I'll just go into the technical aspects of what does that mean? You've got a new infection that's affecting human beings. That means that human beings have not adjusted to it. There is no immunity to it that's specific to that agent. Now, understand that these cold viruses have been around for a whole long time. Almost everybody listening to this has been infected by a cold virus, including a coronavirus. But this is a variant of that that's much more deadly. What it means is we're going to have to develop ways of stopping the infection from continuing to spread through the human populations. How do you do that? Well, there are several ways to do that. One is you prevent it from infecting people in the first place by physical containment. That is, you stay far enough away from each other, you wear masks, you wear face shields. We know that it infects the body through stuff that's floating around in the air, and then it hits your mouth, or you touch something and then you touch your face. These viruses get into your body through the mucous membranes, usually of the mouth or the nose, or sometimes they get all the way down into the lungs, and that's when we get into very serious problems. So how do you stop that? Well, one is you just make it harder for the bug to get from one person to the other through physical containment, and that's why we have the so-called social distancing, and an especially unfortunate term, since it should be physical distancing and social intimacy, but it's what we settled on. And then the other thing you can do is, when you know somebody's been exposed to somebody else, you ask them. And if you catch it early enough, you can identify the people who have the disease or are potentially spreading it. And then you ask them, who have they been around? And then you go to those people and you say, please go stay in a room by yourself for 14 days until this thing goes away, or we're sure that it's going to go away. And it's very practical. It's detect, isolate, and then make sure that you're decreasing the spread of this germ. So that's one thing that you can do. And some countries did that really well. New Zealand and South Korea and even China did a pretty good job once they just detected that this was a problem. That's a social intervention. The other thing you can do to prevent transmission is to develop a vaccine, and that's the technical fix. That's the American way. And we've got, if you've been following the news, there are 3 trials that are fairly far along. They actually, amazingly, made their protocols for how they're doing the initial tests on these vaccines. The first 3 vaccines that are in the queue out of almost 200. Those protocols for how this is going to be rolled out were made public just this week. And there are a lot of hopes that a vaccine will work. There's also some concern that it won't work because these are coronaviruses. And immunity doesn't last very long for colds. We know that. So we don't know the degree to which this virus is going to be like other coronaviruses. We just don't have those data yet. But that's the other thing you can do to prevent things. But you don't have to be able to prevent things to stop an epidemic. In fact, you can eradicate a disease by having a good treatment. And this is what Egypt has done with hepatitis C. So hepatitis C affects 75 million people, 70 to 75 million people on the planet. So more than 10 times as many people have been exposed to COVID are walking around with hepatitis C in their bodies. But Egypt is on the verge of eradicating it from its population, and there's no vaccine. How do they do that? Well, there are really, really effective treatment drugs that actually stop the virus from replicating in people's bodies. And if you take those drugs, the cure rates are 90, 95% or higher. So there's a lot of activity trying to say, well, can we use some of the drugs that we use on other viruses on this particular virus? And remdesivir was the first out of the gate in terms of treatment, and it's actually aimed at stopping replication of the virus. The other drugs that have been used are more for ameliorating the symptoms long enough that you can keep people alive when they're in the acute phases of the illness, and those are the steroid hormones. So you can treat people. And actually, you can get rid of a disease that way if it's a really effective treatment. We don't know if we're going to have that with COVID or not. And then there are other treatments. You take advantage of the fact that some people have survived treatment, have survived infection, and you go to them and you take the antibodies that they have in their blood because they've successfully overcome this virus, and you get rid of the red blood cells and you keep the fluid that has the antibodies in it, and you give that to people who are suffering symptoms and hope that those antibodies can suppress the virus in that new body. Those are the treatments that was the convalescent plasma treatment that was very hot a couple of weeks ago. And now we're right on the verge of trying monoclonal antibodies, which are actually, somebody has reacted to it. You take an antibody that comes from somebody who's been exposed and successfully suppressed the virus, and you try to identify which antibody is the one that's most effective at suppressing the virus. And you make a whole lot of that using whiz-bang technology, cell fusion, and produce monoclonal antibodies against very specific things on the virus to stop it from killing people and harming them. So that's progressing. We're on the verge of having the first monoclonal antibodies introduced into clinical studies. So we've got all of the things. And then the most amazing failure of the US system is, despite the fact that we've got tons of biotech companies and whiz-bang genomic technology unparalleled, we really screwed up on testing. And why does that matter? It matters because if you don't see it, you can't do anything about it. And you can't see a virus. So what can you do to substitute for that? You have to have a technology that allows you to detect whether that virus is in somebody's body or not. And there are two ways to do that for detection. One is you actually detect the virus, the RNA in this virus itself. And you use that by making lots and lots of copies of the RNA. You turn it into DNA, you stick it into a machine and make lots and lots of copies through polymerase chain reaction. And then you say, hey, was any RNA from this virus in that person's body or not? And that's what you use the swabs for. And that says, is there RNA from that virus in that person's body or on that thing that was on the table or whatever? You're just detecting whether there's nucleic acid from the virus. And that's really sensitive, but it doesn't necessarily mean that that virus is contagious. It means that there's RNA left. The other thing you can do is look for the proteins that are made by the RNA in the process of making an active virus. That's called an antigen test. An antigen is just something that the antibody recognizes. And you're looking for proteins that are carried by the virus, and actually only the virus. And so we've begun to develop really cheap and fast tests for detecting whether the virus is there in sufficient amount that you can actually detect it by putting it in a test tube with these antibodies and seeing if the antibodies stick to the stuff that you've put in the test tube. And if they stick to something, that means there was some virus there. And that's likely to be contagious virus because you wouldn't have the protein unless you had the structure of the virus. It's not completely analogous, but it's pretty close. And it's much more reliable in detecting active virus than the RNA tests. And then finally, you can test people to say, hey, have you been exposed? And what you're really measuring there is the immune system reaction to the virus. And that comes in many flavors, but it comes mainly in the antibodies that we're used to that float around in the blood. Another class of antibodies that are from the mucous membranes that are rich, that are much harder for vaccines to elicit a response from. But those are the ones that you would really care about because they would stop the infection from the get-go. The ones that would act in the mouth and the eyes and mucous membranes of the body, those are the IgA antibodies. And the final kind of immune reaction is cellular mediated. These are actually cells, white blood cells in your blood that are going to go in and pounce on the cells that are infected by the virus and kill them. So those are T cell reactions. And the vaccines that are being developed are trying to elicit that natural response to an infection, but without having the infection, by imparting parts of the virus. There are many kinds of vaccines that are being developed. And I'll stop there because that's kind of the technical stuff that you need to do, what you need to say. But let's go back to where I started, which is why in the world, with all these technical resources and this warp speed, and it truly has been amazingly fast progress in the science and trying to deploy technologies against this common enemy, why in the world have we seen the patterns of death and destruction that have come out of this pandemic? And one is, most of these are social factors that have to do with how we organize our culture. One is, if people are given a choice between going into isolation and protecting other people as well as themselves, but mainly once you're infected, you're protecting other people when you go into isolation. If you're faced with the choice of, am I going to be able to feed my family, or am I going to go into isolation and nobody's going to pay for my care and I'm not going to see anybody for 14 days, pretty easy to see why people wouldn't go back to work and spread the disease. You need to, when you're doing a serious effort of contact tracing and prevention, suppression, you need to make it really easy for people to do the right thing. And we haven't done that. We also saw incredibly fast and destructive spread in places where there are high clusters of people who are highly vulnerable, like nursing homes, and in close spaces with poor ventilation, where there are lots of people bumping into each other. Things like, bars, frat parties, and things like that. So those are social things. Meatpacking plants are really good for spreading because they're cold and the virus can stay alive for a long time, and people are really close together and there's lots of biological stuff to stick to and continue to fester. So all those things have to do with the social dynamics, and I'll stop it at that and turn it over, I guess, to Anna. Is that right?
You'll turn it back over to me, and then
okay.
yeah, and then we'll go on to
the last
Kevin.
thing I meant to say, I'm sorry,
That's
Elisa,
okay.
I forgot. I also pulled together this resource page that you very nicely displayed to everybody that I use pretty much on a daily basis now. You know, we're all totally obsessed with what's happening, and what we are following is trying to follow social progress and also social failure of social progress. And these are the sites that I tend to go to time and time again. Some of them are about the cases. Stat News has been doing amazing coverage of what's going on in this space and following the innovation process. New York Times is great. And our own ASU College of Health Solutions, for those of you who are interested in the testing aspects, has got a really cool interactive display of what's happening with different tests that are in various stages of development. And you can follow those in real time and figure out which kind of test and who's making it and all that. And then these two hub sites, one of which I suspect Anna will talk about, from the University of Washington, and Johns Hopkins has become world famous for being the place that is providing us with the information that our federal government should have been.
Good, thank you. Let's see, we can put those, is there a way, Cindy or Kat, that we can grab this slide and put the links into the chat for people?
I'll do that. I'll do that, Elisa.
Can you do that?
I can do
okay,
that
great.
from here. I'll just dump it into the chat in just a minute.
That'd be perfect, thanks. There are a couple things I want to just bring up and kind of put into a parking lot. And Kat, if you can help me remember when we go back to the Q&A to bring this up.
Sure.
So Bob made the point a few different times that the poor response to COVID, the kind of disastrous crisis that we're in, isn't only because the virus itself is new and is behaving in a kind of a different way and is particularly deadly, but because there was some kind of disconnect between the technological and institutional preparedness that the United States presumably benefited from before the pandemic and the way things got implemented. And he's attributing that to social issues, social factors, which is appropriate. I want to emphasize that when we see a disconnect like that, this is why I started by framing it with the social ethics and the underpinnings of what we assume we are doing when we are implementing a response through governmental and other means, right? What are the underlying goals and ethical principles that we think that we are adhering to, that we are working toward? Because sometimes when you see a disconnect, it's not just because people are behaving poorly or showing bad judgment or, you know, sometimes there can be more fundamental things at play. And that's an important thing to recognize. Government systems, governance systems are critical things, and making sure that the purposes are lined up between the formal and the informal channels is as important as making sure that we have all of the technological things, from the low tech, as in masks and social distancing, as Bob mentioned, and all the way to the highest tech sorts of medical treatments and vaccines. So I want to make sure that we go back to that. Kevin, if you can unmute. Kevin is a professor at ASU in the business school, and he both works on sustainability issues with a lot of large corporations across the country, and he is a supply chain expert. Can you tell us a little bit about how and why you got involved in COVID?
Sure, and welcome everybody. Thanks for being here today. And thanks to Elisa and the panel. I'm not interested in COVID more than all of us have been individually affected, obviously. My daughter got married the weekend before everything closed down, so an important family event successfully got completed and no one was sick. So, you know, my interest as a supply chain professor, especially one who focuses on sustainability and climate change, et cetera, is how this is indicative or predictive of the future of our economic systems, which, of course, today in our global economic systems, the economy is the supply chain, right? No company makes everything from you know, farm to retail store, so to say. All companies depend on supply chains. And so as a supply chain professor, when we look at supply being disrupted somewhere, we think about a couple questions. How large is the impact? So what particular supplies are being put at risk? How long is the event underlying this disruption? How broad is the effect? For example, with numerous hurricanes hitting the Gulf of Mexico region, the United States has a large percentage of its petroleum, let's say chemical derivative industries in that area. And so because of that physical proximity, extreme weather events that hit that area have a disproportionately large impact on that particular industry sector, for example. And then we think about where in the supply chain those impacts are. Are they far upstream in the supply chain where raw materials are being extracted and processed, or where we have agricultural or forestry or fishery processes? Are the impacts primarily with, let's say, a manufacturing plant that's in a particular location? And a famous example of that is that the U.S. car industry found out after the Japanese tsunami that they all depended on a single supplier for a very specialized type of paint. No one really knew there was only one supplier to the auto industry until the tsunami disrupted that particular factory, and everyone quickly found out. And it took about 9 to 12 months to recover that particular paint that was gathered a premium on the car price. And so in this case with COVID, we see that it is impacting all points of the value chain, including consumers and retailers and sellers, right? That it is not just about loss of supply, but it's about shifted demand, which is much more complex. So the reason that we have not enough paper products at the grocery store, is the same reason why, in fact, in waste management, the cities that are primarily responsible for hauling garbage and recycling from individual homes have double the work, right? We've shifted demand in the case of waste from the office and the factory to the home. And so homes are now generating essentially the waste and the recycling that would otherwise be generated by a business. However, there are typically two different companies or two different haulers involved in picking up commercial waste and recycling versus residential. And so in this case, the demand shift, you know, we have these optimal supply chains. In one case for waste management, we've optimized let's say business routes and commercial routes versus private residential. The private residential have a low density of trash per mile, and therefore they make the least money. So those are always dumped off, so to say, on the cities, right? And the more valuable commercial contracts, because the garbage density is higher in a commercial industry, those are typically contracted out to individual haulers. In the case of paper, we've optimized our paper supply system for consumers versus the business industry, the business sector of restaurants and hotels, for example. So if you were a consumer and really wanted to go buy some large stocks of paper towels, you could find tons, literally tons of paper towels in the B2C sector. These are primarily, you know, big rolls of paper towels that, you know, you see at a restaurant. They often have a very large amount of recycled content that you actually rarely see in the consumer side product. So one of the lessons learned here from COVID is that because of climate change, and because climate change impacts are both increasing in their magnitude, their frequency, and their concurrency, right? So we have California or East or West Coast wildfires at the same time we're getting hit with record temperatures across the United States. We're getting hit by hurricanes in the in the Gulf of Mexico. So we can expect that whereas extreme weather events tended to be isolated in kind of sporadic points in time, and they only occurred one at a time, unfortunately, the future is going to have a much more hazardous risk profile, and we're going to see these type of weather events or other climate change related impacts such as mass migration, et cetera, impacting our economy all at once. So this is not an abnormal supply chain or economy. This is I think, a portending of the type of volatility and therefore the type of resiliency that we need to build into our economic systems. And I tried to pull apart as best I could the notion of public interest technology. And I'm not new to technology management, but I am new to this particular concept. So hopefully I've interpreted this correctly. But here's a business school prof play on this. And that is, just speaking for the US, the US is a market-driven society, regardless of the political parties in charge. It's built into our core. And as such, we should not expect too much giving up of that private concern in times of special need, or giving up of those private concerns for the public good, for better or worse. In my mind, as I'm not a policy person, I'm a business person. I'm just trying to interpret what's going on around me, and I work a lot in the recycling and circular economy realm. And, you know, we're looking at policy versus market forces and stuff. And the bottom line is that if we look at masks, we can see both the success and the potential failure of such a strong market-inspired set of values and practices. So on the negative side, if you step back and look at this at a system level and look at it as a supply chain management problem, anyone in your first course in supply chain management, you would learn for your critical supplies, centralized purchasing. Centralized purchasing. You're going to put your best purchasers at the table to do that centralized purchasing. You're going to be able to follow certain principles and guidelines that lead you to make strategic decisions. You're going to get better cost, right, because you're buying in aggregate. Rule number one, centralized purchasing for critical supplies. Could you imagine, for example, that the university would allow a individual department, academic department, to purchase, spec out, purchase, and oversee construction of a new building? Now, the college that's going to reside there or whatever, of course, could be deeply involved, but the university itself has the expertise, it has the supply connections, and it has the processes really to efficiently and effectively spec out a new building, find the relevant suppliers, and oversee that process. I understand that there are political reasons why we did not centralize purchasing, but in my mind, we lost at least 3 to 4 months of response time by relying on the private sector to self-organize a response versus having a predetermined centralized response to that critical or those types of critical medical supplies. On the silver lining side, I would say if you look at the proliferation of private, and I would say collectively private action that Lisa referred to earlier, it's amazing, right? It's the American spirit. And so on my social media, all I see are all these advertisements for all these different masks. And I don't know if how some of them are good, but I mean, in terms of like I know that last Christmas, I bought everybody stickers. Like stickers was the big thing, right? Because we all have water bottles and we want to put stickers on water bottles and on our notebooks. And so a lot of my Christmas stocking stuffers were stickers. This year it's masks. So, right, the creative energy of our world of art and graphics has been unleashed on masks. So, you know, where else but in America? My guess is if you looked at global purchases of masks, you know, I don't know what our supply is on the commercial market, but just like pop music, I would bet that, you know, people around the world are attracted to our artistic flair for our masks. You know, we didn't think about the waste that would be created by this product. So just like America to have, first of all, way more masks than we need overall, but not distributed in the right place, right? So you still have doctors that don't necessarily get access to N95 masks. But here at home, I know they're not N95 masks, but we must have 2 dozen masks in the car, in this bedroom, on this dresser, and just like America, or just like me at least, our family, to be overly consumptive. But then also not really worry about the end of life, right? And so the fact is that what we're going to do with these masks is primarily throw them in landfill, but we don't really have another solution for textiles anyway, right? So that's just a systemic problem. As just to kind of close on what I think is what I observe as a positive example of public-private public interest technology is that if you start off on the public side with the Intergovernmental Panel on Climate Change, IPCC. The IPCC, was formed, I think, about now 25 years ago. Its purpose is to interpret the science related to climate change and then present those interpretations of peer-reviewed science to policymakers and the public, and very importantly to commercial entities, to private entities. And they have agreed on standards, they have shared data, they have shared computational models. It's not to say that there is not active, energetic debate among scientists within IPCC about assumptions, validity, validation, et cetera. But nevertheless, it's a collective effort that has, to some extent, the ego and the reputation of the individuals involved in it has been subsumed to the greater social need to create a kind of uniform view of this critical issue to the public. So you have that emerging on kind of the academic and maybe to some extent including the government laboratories and whatnot. Then you have, following in the last 5 years, the example of the Science-Based Target Initiative. So how do corporations help us meet our global commitment to a 1.5 or 2 degree increase centigrade future? Well, they do it through following the algorithms that are part of the Science-Based Targets Initiative. And so what scientists have done is they've figured out, here is the proportion of greenhouse gases that really corporations are and should be responsible. And if you're therefore a corporation, we can give you the algorithm so that you as a single company can kind of calculate what are the goals that you should have, that if indeed all corporations followed this methodology, we would collectively meet our climate goals. And this is, to some extent, it's hard to find an example where companies have given up their goal setting to an algorithm, right? So when a company commits to science-based targets, they're committing to a share of collective responsibility that is beyond their kind of interpersonal or power-related negotiation skills. They are giving up their goal setting to an algorithm, and whatever comes out of the algorithm, so be it. If they're committed to this collective goal, they have to accept that. So to me, that's an exciting example where you have innovation on the kind of public-private side to create a common base of science to draw from, and then you have corporations collectively committing to a methodology that allows them towards a movement towards a collective goal. And we see that so much in the sustainability world these days, where companies are getting together. In the US, there was just the launch last week of the US Plastics Pact. And again, these are corporations who are making a collective commitment towards a certain amount of recyclable content or biodegradable content within their plastic portfolio by 2025. So it does seem that companies are beginning to see that whether it's giving up their own intellectual property, as Nike did when it gave away its intellectual property to the Sustainable Apparel Coalition many years ago, or it's making collective commitments that they have to collaboratively engage on to meet their public commitments. I'll stop there.
Yes, thank you, Kevin. Yeah, so that was pretty fascinating, and I didn't realize that you were gonna weave together climate change and COVID and the whole ball of wax.
I think I can find a climate change connection in everything I look at these days. So that's just my glasses.
Yeah. No, I think it makes sense. There are a few things that I want to highlight from what you said before we move on to Anna. One is that you talked about in several different ways, the importance of science-based targets. So the importance of science-based criteria for trying to figure out what it is that we're trying to achieve. This is not necessarily to say that the science-based targets are going to preempt policy goals that might be different, but they really are important. And you've made the point that, you know, what I refer to as civic engagement or public engagement, we're talking about, say, non-governmental. In this case, you're talking about the collective action of the private sector, right? As well as in some ways synergizing with some of the public engagement that we're talking about.
That's right.
And that it has its own sort of rhythm and its own way of doing things. And we have seen, as you say, that some of the innovation has really come from that collective spirit, really, for trying to solve problems in whatever way. And I have also noticed that there does seem to be a sense that there's reason to make a hypothesis that it's because of the failure or the perceived failure of the public response compared to what we would expect, what we'd normally expect, that may have triggered more of this sort of surge.
I think it's there already.
What's that?
I think that train is already long gone, in my opinion.
Well, I'm saying that it's hard to know. You mentioned it, you talked about it as a silver lining. It's kind of hard to know whether we would have the same level of innovation across the board that we're seeing without that initial, like if people had felt complacent that, you know, the public managers have this in hand, we don't have to worry about it. Would we still see some of the innovation that we are seeing? It's a worthwhile question, but it's one that's worth asking and actually critically analyzing. Same way you mentioned that the initial response to the pandemic did not follow supply chain 101, right? And supply chain 101 is the normal public response to a crisis. And so you said that you thought that we lost probably 3 to 4 months. This is what I meant in my presentation, in my words at the beginning, that doing things that are different from the way they're normally done is innovation, and innovation isn't always beneficial. So this idea, one can analyze where it came from, what it's based on, but there was an idea, an explicit idea that was acted upon to not rely on traditional public management strategies, but instead to allow the public sector to, as you say, self-organize.
Understand. And
yeah.
I think that, so there is a theoretical reason, though, why I would stand by my premise. So if you maybe distinguish between two types of solution spaces, right? In complexity science, it's called the rugged landscape model. But it really applies to kind of any design problem. And the question is, if you look at a landscape and you think about the goodness of a solution somewhere in that landscape as the height of a mountain or a hill or a valley, and your job as a designer is to find the highest point in that solution space, right? The best solution. Now, if it turns out that there's only one best solution, there's only one big mountain somewhere in the landscape, it doesn't matter who you send out. Eventually, to search for that mountaintop, eventually everybody will find the same top of the mountain, right? And so the only reason to have kind of multiple search parties out searching for the top of the mountain is just to get there faster. But once everyone gets to the top of the mountain, everyone agrees, oh, this is the best solution. Right? Now imagine a landscape that is, you know, like the old golf course ASU used to have, where it's just these rolling hills and there's lots of kind of hills in a neighborhood that have height. And your job, there's 1,000 hills out there, 1,000 solutions. They all look pretty much the same. They all look viable. How do we find the best solution? That's really where you need to send out kind of individual search parties to search those different neighborhoods and find that local peak. But you still need them to communicate on what they're finding in their neighborhood, right? You don't send out these search parties and then not hook them up with walkie-talkies. Our private approach, which was exemplified or is exemplified if you look at some of the large-scale technology bids that the government has put out, you know, whether a pit of Boeing, you know, versus a Honeywell, and each kind of go off and design their own thing and they don't communicate with one another. That's great for creativity. Once you come up with a solution, though, and you know what the solution is, it's stupid not to centralize resources. So I agree that searching for a vaccine, you want a lot of independent teams loosely connected, not overly connected where they're constraining the solution space. You want as broad an exploration as possible. But once we find a vaccine, we need centralized, we need coordinated production capacity. There should be one best way to manufacture that vaccine that should be easily findable. And what I worry about is that our private concerns will keep us from the collective capacity that we could have if, for example, that intellectual property that's discovered is in fact made public, so that any manufacturer could pick up that. And I would say that in making masks, there was no creative task. So we didn't have to, we didn't need a market solution with a bunch of concurrent kind of emergent discovery processes to figure out how to make a mask. We knew how to make a mask. And so we should have centralized immediately. Whereas with a vaccine, I think it makes sense to have a distributed system for searching and creation. But again, once you come up with a solution, at least structurally, it makes sense to centralize.
No, that's really interesting. We'll move on to Anna now, who will bring us back to the ground when it comes to thinking about the pandemic. But I just want to put you on alert, Kevin, that a number of people in the chat are wanting to bring up the sustainability issues related to pandemic responses, so we might get back to that. Anna.
Yes.
There you are. Would you like to share a screen, or would you like to speak without slides? Okay.
I'm going to share a screen just because I think visuals make this a little bit easier.
Okay. And if you would just take a couple of minutes while you're getting yourself set up to just give a little bit of your background, which is a pretty interesting and relevant one, and explain what you're doing, that would be great.
Sure. So, hi, everyone. I am Anna Muldoon. I am a doctoral student in the School for the Future of Innovation and Society. I am also a research professional at ASU. So COVID is actually exactly the kind of thing that I work on and have for most of my career. I have a master's in public health with a focus in health policy. And I have worked in and around infectious disease since 2009. So this is in fact exactly the thing I am and always have been interested in. I just sort of hoped it wouldn't be this bad when it came. So before I came to ASU, I spent nearly 10 years at the Department of Health and Human Services in the Assistant Secretary for Preparedness and Response, which works on preventing, well, exactly what we are experiencing right now. So I have been doing this for quite a long time. And with that, I am going to talk to you just a little bit about modeling and data and the complications of all of that in COVID. So, no, go over there. Sorry about that. There we go. So this is the most basic, these are two versions of the most basic form of a model, right? A model is just a representation of the progression of a disease. That's it. At least this type of model. So they can be incredibly simple. Someone doesn't have the disease, they're susceptible, they get infected and they're infectious, and then they recover. That's the basic version. Now, I suspect by now you guys all know that COVID has not been that kind to us and is a little bit more complicated with asymptomatic spread and pre-symptomatics. It's a bit more involved than that. So don't scream. I promise I'm not going to make you walk through this next slide. I promise. So this is where we ended up with our model, which is significantly more complicated than the very basic susceptible, exposed, infectious, recovered version. But this was necessary because the entire goal of modeling is to accommodate the progression of the disease. So COVID is a complicated one, right? It takes a while for, particularly in the early days, took quite a long time for cases to show up in testing. The asymptomatic spread versus pre-symptomatic spread were deeply unclear for the first many months. So the process of building this model was sort of definitely building the plane as we were flying it, but also was a process of constant change, constant rearrangement, constant searching of literature and the discovery of new information as we were attempting to build the thing in the middle of a crisis. So it requires a lot of brain-bending thinking around whatever disease you are dealing with. And I would say for most diseases, there's no such thing as a perfectly standard model that you don't have to adapt to fit the disease specifics. So I'm actually going to skip a couple of these. But just to prove the point of exactly how complicated building models, particularly for brand new disease, can be. This is the performance on, I think this one is national, models of a subset of the models that exist for COVID. And as you can see, some of them have done really well. Some of them did well for a while. Some of them have not done so well. And it's partly because everyone is trying different approaches, right? So everyone tries different approaches, and eventually people start to converge on methods of looking at what we think might happen that work. And this is just for entertainment, the same models, but ranked by how they performed on state level projections. Meaning, some of them got national really right and state really wrong, and some of them got state level really right and national really wrong. So that's where I'm going to stop torturing you with slides that have a lot of numbers and a lot of diagrams and just talk to you. So at the beginning of this outbreak, we didn't know anything really about COVID. We learned pretty quickly that it was a coronavirus. We didn't really know how it was spreading. We assumed that it had originated in Wuhan. Turns out probably was around before that, and that was just the first big event. So as we moved into the outbreak and moved into tracking local data and national data, everyone was kind of scrabbling around for every piece of information they could find. Every article that came out would immediately get picked up and discussed for whether it needed to adjust our probabilities inside the model or what it told us about whether the structure of the disease dynamics we had built was right. And so as time has gone on, the ways that we approach all of these things has adjusted. Things have solidified a lot more, right? People are not still fighting about whether asymptomatics can transmit COVID. They can, we know this, but we didn't. 4 months ago, there was still debate. So it has changed incredibly rapidly. And it's a technology cycle basically that goes at light speed. And thankfully is pretty cooperative, right? So people from a lot of universities talk to each other and share information and discuss their models and try to see whether they can help each other improve them, because the entire goal is simply to have some idea of where the disease is going and where it's taking us. So in order to talk to you about modeling, the second piece is actually the really basic ground truth data collection piece of this whole situation. Because all of these wonderful compartmental models that help us understand where we might be going can't function if we don't have good data. And in this pandemic, we have seen a lot of data issues that I don't think most of us really expected would be as much of a problem as they are. You know, I am very sure that there were some people who expected this, because there always are, but I think most of us did not think that we would have this much difficulty even knowing how many cases there are in a given place. And that has been a collision of factors, right? That it took so long to spin up testing, that many people were using different tests for a long time, that some were better than others. And then, of course, issues with data collection and data reporting, that for a while, not everyone was reporting the same data. Not everyone was reporting data the same way. And there have been moments when, you know, different states are actually using different case definitions for what's a confirmed case and what's a probable case. So it makes actually working with the data, the very data itself, that is the ground truth you need to do all of this work, to track, to understand the demographics, to understand how fast it's spreading, how it's spreading, who is most at risk, and then from there, hopefully, to also build some projections that give you an idea where you're going. That ground truth data is the base for all of it. And when there are problems with the ground truth data, it starts getting a little bit interesting. So we've spent a lot of the past 9 months, by we, I don't just mean my team, I think I mean the public health community possibly as a whole, dealing with things that probably most of us would assume that in this world of interconnected technology and rapid communication wouldn't be problems, right? Making sure that we can all get clean data that's comparable across states. Like globally, that's even harder. And the bigger you go, the harder the problem is. And the more complicated the approach is to try to make sure we have good data that can be worked with, that really does lead us to the right conclusions about what's happening, can be. So, you know, Bob posted the Johns Hopkins website that has the beautiful map. When they got that website up magically fast. It was amazing. It was the early days when, you know, we didn't even really know where COVID had gone. It was not yet called COVID or SARS coronavirus 2. It was still just the novel coronavirus. And it started popping up in tiny spots, and the map watched it spread. I kind of hope somebody has daily screenshots that they can turn into a video as it spread across the world. I am very sure somebody does. But that map and the data that was coming in on it became a crucial point for a lot of us in the early days, when information was not very available, when everything was changing incredibly quickly. Those kinds of public projects that compiled data, that got data out there where everyone could see it, were a crucial piece of coronavirus response, and I think a very good example of public interest technology. That is exactly the ways that we would all hope we could use our technology, our data, and our energy to get information out there in the middle of an outbreak. So I think it's also worth noting that we now see everyone creating COVID trackers, right? The New York Times has one, the Washington Post, Hopkins. I could not list them all in the time we have available. And they're all similar, right? But everyone takes their own tiny slant on how they want to look at the data. We have some standard measures that most places report, you know, the number of cases, the number of deaths, the number of hospitalizations, the number of tests, the percent positivity. These have become standard measures that people, I think for the most part at this point, understand at least what trends in them mean. Most, I think, public health people never actually thought we would be discussing the differences between RT and R naught in public, well, ever, but that has also become a joyful activity. And so those trackers are another kind of example of how the obsession and the use of public technology has really created this crazy amount of information that is mostly the same information, but not quite. And the digging through it gets really complicated. So there are so many other things that I could talk about that have happened with data and modeling and epidemiology in this moment. But I think I'm going to pause there so that you guys have time for questions. Unless, Elisa, you'd like me to keep going.
Actually, I think this is a really an interesting place to stop, because what Kat is going to be talking about is some of those surveillance approaches, which are a different way of thinking about using that data, right? When we get to the Q&A, one of the things that I'd like to sort of have you tuck in the back of your mind are some of the analogs to some of the things that Kevin talked about, but in terms of data. So he talked in terms of supply chain 101, and like once you know the answer, it's good to centralize it, right? You didn't address, but we can talk about it, you know, during the Q&A, whether the kind of data standardization issues, the kinds of problems that you're talking about, whether they're normal or whether they're somehow worse in this particular case because of the disaggregation of how testing is being done, you know, kind of like across so many different parties that therefore will have different, you know, procedures. So I don't know if you wanted to comment on that now, or if you want to just kind of hold on to that.
Sure, I'll make a quick comment on that now, and if people want to follow up, we can do that. I think that it is guaranteed that in any outbreak, particularly one that moves this fast, there will be data issues and there will be conflicts about data collection and case definitions and test sensitivity and specificity, right? We've seen all of these things. And there will always be fights about data interpretation. I am not actually convinced that centralized data solves all of the problems, because some of the problems are just ground truth problems in how working in this kind of incredibly rapidly shifting landscape of disease goes. It's always unpredictable, it's always changing, right? So I think to some extent, those problems can be solved with better communication, but the things that are simply a facet of infectious disease, and particularly emerging infectious diseases, they just are what they are, and I'm not sure that those will change in any outbreak ever. They've been the same forever, and I think they will stay the same.
Well, that's great, because now Kat can help us understand how the different methods that people are using for surveillance just iron out all of these data problems so that we can have full confidence in what they tell us, right?
It's nice to be with you, Lisa, especially to come after Anna, Kevin and Bob and yourself. Well, where do we start? The first thing is to say that this is not new. We've been trying to track pandemics since around 2003 using these lovely shiny devices called smartphones, but at that time they were sort of 1.5G, not even 2G. I came out of a company, Nortor Networks, that spun off a 200-person sized company called Andrew Corporation and later CommScope that actually deployed the first mobile alert system in Hong Kong within 48 hours. Just took them 2 days with Sunday Telecom. And that app was one where you SMS'd a number to receive a mobile alert as you came towards a SARS-infected building. And having lived in Asia all my life, Australasia, we're not new. It's not new. Pandemics are not new to us. We can go back to SARS, we can go back to avian, we can go back to the swine flu, of course, which many people underestimate. I mean, about 6 million people came down with the swine flu, and there was a vaccine response. There was MERS more recently, and now we have COVID-19. And so I'm just going to show you some sort of historical documentation which demonstrates how much the Australasians have been thinking about this. So back in 2006, we published this for the Australia Research Network that was about securing Australia. And it was an avian flu tracker. I had just come out of industry 4 years previously, and we were looking at a location service proof, and we were working with a telecommunications company to use their location servers that polled devices in the field to see whether someone was in a quarantine zone, potentially, to see if someone was coming into a contact with someone who was COVID positive. And it was all about simulation at that time. Remember, it was a proof of concept, but apps were around. We were looking at 3G. I had just been involved in 3G auction spectrum bids all over the world. And so I knew that this thing was coming where we'd have more location intelligence. And just to trigger everyone's memory, it's not like nobody died as a result of avian. We even have not eradicated in some parts of the world avian, and the same with SARS. It still exists in remnants, but the number of cases of deaths were nowhere near what we've seen today with COVID-19. And so we, went to business and had some scenarios and created this particular application, which looked at individual confirmed cases of avian, and then how we could mathematically simulate this in an environment which was location-based using geographic information systems. You could have a dashboard, you could see alerts, and the whole idea was, well, if we could have health surveillance and visibility, possibly we could reduce the transmission rate of a pandemic outbreak, whatever that pandemic was. Of course, we held annual workshops on this. We had a wonderful doctor from the Cochrane collaboration come to us, Professor Chris Delmar from Bond University at the time, looking at tools of evidence-based practice in making decisions on national security. And here, when we look at pandemics within the realm of national security, we're really talking about social securitization. We have to securitize our populace from disease, from pandemics. And one thing that we took away from Chris's talk was that we would have to have an emphasis of three things: vaccination of the population, if a vaccination existed, the stockpiling of antiviral drugs, which is what Bob referred to, and physical barriers of hygiene methods. And, wow, he told us the transmission could be reduced by 30% in a pandemic if we just washed our hands properly. 30%. And I still go back to this fundamental process of washing hands prior to a vaccine becoming available. And that's what we're seeing and being encouraged. I have talked to many parents who say, isn't it amazing that this year our kids haven't gotten as sick as previous years because everyone's conscious about washing their hands more often. And if anything was to come out of this pandemic, just that would be enough to ensure that we generally reduce the transmission of other disease that was transmittable either through saliva or bacteria or some other thing. So that's a bit of an opener. Chris's main message of just wash your hands more often was heeded, but why now? These tracking systems, this AI, this potential to visibly see a pandemic hit before it actually is known to the community at large. How can we simulate? How can we watch? How can we be vigilant? And so I had one security guy back in 2004 say to me, Katina, I think it's really simple. One day we're all going to have devices strapped to our bodies. And he said, if I want to check, where there's an outbreak, I'll be going. And I said, really, that simple? And he said, yeah, and it'll be near real time. I'll have the data. We'll be able to respond really quick and the world will be fantastic. And I said to him, of course, he was defense personnel. I said to him, but do you think the public would accept this? And he said, well, they won't have a choice in the future as all of these dynamic things are unleashed, whatever they might be in society, whether it's trying to bring down crime rates, whether it's a pandemic outbreak, whether it's school education, whether your child is attending school on time, and all of these other things. He said, we're just going to have this global dashboard. And I've seen this global dashboard in the Australian defence orientation, particularly with critical infrastructure around about the time of post 9/11. And many risk-oriented applications were built at that time, particularly to mitigate against short-term things like perhaps a crazy person going and killing 50 people down the road at once within a 2-hour period versus knowing what to do in a natural disaster. One of the Geoscience Australia GIS maps that I saw around about 2006, around about this presentation time, was looking at how can we secure our businesses users, their other businesses, and this notion of a B2B, a business to consumer, critical clients, clients that rely on critical infrastructure. We looked at particularly water, which powers electricity, electricity which powers telecommunications, and telecommunications that powers banking. All of this interdependency in critical infrastructure. And humans are the most vulnerable a node in this entire system. So how can we securitize people? And so we're going through this digital transformation process. That's what I'm going to call it. Governments across the world, they had mobile government strategies, and now they're going towards digital transformation. It's the ripe time, I think, in many countries to be experimenting with the potential to reach your citizenry through this humble smartphone, which now such a large portion of the world actually has ownership of. How can we create bi-directional feedback loops with the end user? Here I'm showing a GitHub environment. GitHub is where you put software that's been compiled with use case analysis and other kinds of scenarios and maps and the actual open source code. And in GitHub here, it's an example of an application of knowing the supply chain and understanding where masks are available in pharmacies in Taiwan. Now, Taiwan has one of the lowest transmission rates of COVID. And what they've done is built an app looking at the availability of masks in particular pharmacies in an area near you. And what that tells us is that the government has an excellent visibility on perhaps where people are buying masks, where there's a shortage of masks, and areas of concern where there isn't an uptake of masks because there's a huge availability or oversupply. It's a very interesting kind of thing. Wondering as well whether people who go to buy these masks at a pharmacy actually use particular kinds of cards to access the purchase of the masks. So a very sort of indirect but very direct knowledge base of mask availability and transmission potentially. So this notion of mobile government, just-in-time practice, contact, location, and condition. Together with Dr. Roba Abbas, I've spent maybe the last 16 years looking at the availability of apps that do look at contacts, do look at location tracking, and do look at condition monitoring. And if we start with the fundamental contact tracing concept, we've got this manual process that has been in existence through the World Health Organization. And we've said, now we're going through digital transformation. Now everyone has smartphones. Let's automate that contact tracing process. And contact tracing is about relative positioning. It's not absolute. It's not my X and Y coordinate on the Earth's surface. That's location tracking. That's knowing someone's exact location versus someone's relative location to someone else. So we had this big debate over whether we should have centralized or decentralized architectures in the software, whether we should go with just a contact tracing app or a contact and a location tracking app. And then we've had some more recent innovations with condition monitoring. And the form factors involved with all of these things, they vary. We have seen apps deployed that do rely on Bluetooth low energy, using the Bluetooth sensors in smartphones. But not all smartphones have the same level of BLE sensor in them. And so sometimes the apps that have been created work properly and other times they don't. Australia had a case where they didn't. Australia just adopted the Singaporean Trace Together app and sort of amended it and landed in trouble when the app that they tried to amend really didn't work with the Apple and Google devices that were proliferating in the Australian community. Other issues that we saw that halted the progress of Australia's contact tracing app, which was also seen in other nations, included accessibility issues, included only having the app available in English, included the fact that kids don't always run around in the playground with smartphones in their back pockets, despite that they were being encouraged to do so. And parents were being told by the government in Australia, get your kids to download the app. People with cognitive issues, issues to do with bugs. There were so many bugs. People were receiving alerts through COVID Safe and being told that they were coming into contact or had come into contact with someone with COVID, a confirmed case of COVID, when in fact that was false. So people lost trust in the actual app. And I'll show an example here where I started to model, and again, going back to Anna's wonderful presentation, you have to know, if you're going to say, we're going to rely on social securitization and we're going to go to this with a technological response, you have to know the number of people in your country, the number of children in your country or that space, maybe it's your state or your city. You have to know how many people actually do have smartphones. What's the penetration rate? Does every single person have a smartphone, or is it a smartphone per household? And what about that discrepancy when people share mobile devices? The eligible target audience, therefore, is estimated. And then you look at market share. The iPhones, unfortunately, had a greater issue with many contact tracing apps across the world. They weren't registering through their BLE sensor that someone had come into proximity with them, and they weren't exchanging anonymous identifiers between phones. And then you had the Android issues, and we have a whole list of these. Australian security researcher Vanessa Teague went on to GitHub publicly with friends like Chris Culcain, Eleanor McMurdy, and Robert Merkel, and basically said, here are the issues. We've got payload encryption issues. We've got spoofing issues. We've got consent issues. We've got other issues. And the technical community responded saying, why didn't you give us these apps in open source? So we could at least help you overcome some of the preliminary teething problems, which would have meant that the Australian public would have had greater trust in the app and greater trust in the outcomes of the app. And so we could go through this whole list, but I won't bore you. The other thing is that the individual nation states that were investing heavily in their own government-oriented apps were trying to keep beefing up these numbers. Oh, we have 1 million downloads in the first 24 hours. Oh, we have 2 million over a week. But what happened was we weren't seeing these public numbers being advertised widely in newspapers. So I took it upon myself and started monitoring how many downloads of the app were occurring daily, because the government surely wasn't exposing this. The other thing they did is they got security people like myself and Vanessa Teague and basically tried to silence us in the first days of the actual app, when we realized there were issues with the Apple implementation and the Google implementation in terms of the Australian COVID Safe app. So the app only cost $2 million, but purportedly the number in terms of marketing reached something like $65 million because they wanted people to download. And they kept going on about, well, it's not going to be mandatory initially, right? It'll be voluntary initially. What did that mean? And Australian citizens really responded in a way that was unpleasing to the government when that kind of rebuttal occurred. The other thing that happened was, well, we don't really know where these 6 million downloads purportedly came from, like prove it. And then multiple upgrades of these apps. And, you know, if I downloaded it in the first week, do I need to download it again next week and in 3 months' time and today? And this agreement that finally came in terms of exposure when the government conceded that the app they had built wasn't actually working effectively, and they would be calling on the help of Apple and Google with their decentralized system. And so a bit of transparency goes a long way in these things. The other thing that we started to see was pressure from various governments. Okay, we have a contact tracing app. It doesn't locate you. It doesn't say where you are on the Earth's surface, but it tells us about your proximity to others that could be COVID positive cases. And so then we started to see this sort of fear mongering. We've bought GPS anklet devices for people that don't comply to quarantine. in places like Hong Kong now, you have a wristband that is worn during quarantine when you should be self-isolating. And if you go outside, your neighbor will surely snitch on you. And we've seen this as well through legislation here locally in Australia, where I am. A family of 4 were coming back from a COVID area in Victoria and were actually dobbed in by their neighbors for actually being outside and not quarantining. They were fined around about 10,000 Australian dollars. So apart from the anklet bracelets that remind us of criminality, apart from these bands that we wear during quarantine, we've also been tinkering with Fitbit devices. Stanford University and Fitbit came together to offer a predictive kind of artificial intelligence-based approach. So you self-organize within the study, you know, you'll volunteer your time, you'll wear the Fitbit, and we're trying to see if we can see symptoms before they actually hit for future pandemics. We've even had drones surveil us, and we are talking about swarm intelligence. If a pandemic that was more aggressive than COVID-19 was going to hit, what would we do with drones in the air, surveilling downtown locations where people congregate, looking at people's behavior and their condition? So we're going from this innocent, perhaps, contact tracing to this location tracking continuous, not discrete, to this, well, we'll just put up some drones and have a look at how you are. And the threats that came from the local New South Wales government here in Australia was during the Easter period in April, whereby we were told, if you're found on the road and you're going between an originating and destination point and there's no real essential business, you're not buying drugs to make you better, you're not visiting the doctor, you're not buying essential supplies, we're going to use automatic number plate recognition systems to make sure you're not breaking the law. So with that, I want to end with one slide, and that's the government as innovator, but public-private partnership that's occurring in what we used to call this valley of death scenario, where we invent, you know, the COVID Safe app really was sort of in a valley of death. And if the private enterprise didn't come in to save the app, it would be completely dead today. And so in the public interest, we're going from this app's going to make us money mentality to an app that's about care. And that's in the public interest, right? About health and well-being, about economic prosperity for the public. So what we're trying to do is shift away from this privatized model to this public, and the government as an innovator, the government as a digital transformer, the government as someone who's willing to come into contact with private enterprise to develop something that actually works. And we could look at China examples and a long history of experiments where they've created public-private sandboxes. And I don't, you know, the word private within China is a bit dubious, but they've created sandboxes where they test their pollution-oriented apps, their rideshare apps, their policies. And then they say, right, it worked in the city of Nanjing, will it work now for the rest of China? It's a bit like what the Wright brothers did when they tested models in increments. Finally, can a whole of government approach work? Can public-private partnerships work? And then who owns the data is the big thing as this is proliferating. Does the government own it? Does Apple and Google own it? And what does that mean? So I'll end it there, and thank you for listening.
That was great. Thanks, Kat. So I've seen that there is been an active dialogue going on in the chat box. So rather than try to look at some of the questions that might be left over there, I'm going to suggest that we just all sort of come together and just kind of have a conversation, an open conversation with whoever is here participating. I'm going to put everybody on a grid. And folks can raise their hands if they like, virtually, or just unmute yourself and pop right in and ask any questions of any of the panelists, or panelists can ask questions of each other.
So I had a question for Anna. You didn't really get into this, but I'm really, really interested in what you've learned by doing all this whiz-bang math and surveying everything that's known about modeling and all that. And then you present the data to people who are going to make decisions about closing bars and opening restaurants and opening schools and dealing with the political apparatus that is Arizona. So tell us a little bit about what you've learned about that process.
It's very complicated. So I think I am very lucky to work on a deeply interdisciplinary team where a lot of us have long-term experience in communicating with policymakers from a variety of angles, right? And that has made a huge difference. But I think one of the things that we have found is that it is very difficult to explain the difference between projection and prediction, right? We are not saying this is what's going to happen. We are saying, given the current conditions and social choices we have made, this is where we think we are heading. So one of our approaches to dealing with that, one of the slides I skipped actually, is to give people scenarios. So to say, you know, if masking reduces transmission by this amount, this is what the curve of deaths would look like. If, you know, masking decreases transmission by this amount, this is what it would look like. Because of course, in the early days, we didn't know. So it was all guesswork. And I mean, it's educated guesswork, right? There's some historical data, and we know from other diseases that masks can make a difference. So it's not, you know, a shot in the dark, but it's still basically guesswork in the very early days of an outbreak. So the scenarios, I think, were really useful to people in helping people think through the options they had on the table. And of course, as more studies were done, as different areas did different things, we could give people better and more accurate, clearer scenarios. The other thing is, wow, does data viz matter? How you visualize your data, what colors you use, what your lines look like, right? Are your lines thick or thin or points? It's that minor. But we, I think, have put a lot of time and a lot of thought into how we visualize our data now and why, and what we learned in the first, you know, couple of months of doing this through trial and error about what visualizations really get people to think in the ways we're trying to help them think, and what makes that easier, what makes that harder, and how we can do it better. So sorry, that was a slightly longer answer than I really meant to give, but.
Anna, can I ask you a question? How do we get authorities to believe your projections? Because I do know they were accurate and they probably could have helped the state of Arizona significantly. What can we do? What other public engagement strategies could we have utilized to get a bidirectional listening happening?
I mean, I think it is a difficult question in the context of an outbreak that became very political very early, right? To give people information that is really deeply and truly not what they want to see. So I think that it would have helped if we already had pre-existing long-term relationships with more of the people involved, both in the not-for-profits in the space and in the Department of Health. And, you know, I can hope for the future that politicians will not be in the space of attempting to manage a pandemic that has become a political hot potato, right? I think that is deeply frustrating, both for everyone who's trying to do the right thing in the pandemic. And I'm not even sure quite where I would lay the blame for that at this point. But so I think that long-term relationship building is really important, and that probably would have made the biggest difference. Mm-hmm. Sort of mutual trust is really important in a crisis, right? This is a social crisis, and I think that trust from the public, between universities and government officials and epidemiologists and modelers and virologists, and right, like we all formed these teams so quickly. And I think it would have gone better if we had the things that we now have in the beginning. But of course, we didn't know what they were going to look like when we started building them. So hopefully we'll be better prepared next time.
I think there's really fair comments, and the political aspects of this are, there's just a lot that could be unpacked about that. And there's a limit to how much communication per se, clear communication can, sort of like deal with that. So, but trust is certainly huge. Does anybody have any other questions or thoughts? Anybody that was not a panelist who might want to jump in and make a comment? Toby?
So picking up on that theme of trust, it seems like it is a thread that weaves through most of your presentations, actually, whether that's individual community members' trust in institutions, whether that's trust between parties who are in decision-making role, as you were just talking about, Anna, whether that is, and it seems complicated by a lot of factors, but a couple of factors particularly. One is the deluge of information that we have and the many streams that we're receiving it through, particularly with social media. And then also the evolving nature of our scientific and medical knowledge about the disease itself. As you were saying, as information evolved and became clearer, it was possible to have better projections, right? And better data to share with people. And it seems like technology has a role in that as well, right? Because this technology is about how we're creating information, how we're sharing information, and how we come to make choices about the veracity of information and its applicability to our lives. So I don't know if anyone has anything to share in that way, but on one hand, we have sort of like this diversification of innovation and options, but when you're facing a crisis like this, it feels like in some ways you want fewer options and clearer information, which isn't always available. I don't know how to sort of how you weave through all of those complexities to choose the path forward.
Make a quick comment about that. There's one of the critical kinds of technology that goes to some of what you're talking about, Toby, is social media. And there are lots of different varieties of social media. And through social media, people actually have access to other kinds of literatures that are not themselves social media, right? But it becomes a door to information from a lot of different sources, including peer-reviewed science, including policy documents, including, journalism, all kinds of things. And I just want to comment that there's a double-edged sword about this. So on the one hand, it is probably the case that because social media has evolved in a way that both allows people to have broad exposure to a lot of kind of information and a lot of different sorts of people, but at the same time allows them to figure out like which communities of interest they are part of, which then leads to the kind of clarity that you're talking about, but also may narrow their exposure or may narrow the criteria they use for deciding what's legitimate and what's not legitimate information. So ironically, on the one hand, the very thing that can create too much narrowness is also something that contributes to building this kind of social cohesion that allows for mobilization and engagement within, right? And then this morning I saw, do you guys know who Cass Sunstein is? So Cass Sunstein's he's a law professor, but he gets involved in all kinds of other things. He's famous for nudge, this idea of nudge behaviors. And he posted something this morning reminding us all that 20 years ago, he wrote a piece that talked specifically about social media and projected that the way it was being utilized would in fact create small communities of people, so that rather than have shared understandings that are the bedrock of democracy, we would end up being fragmented into different communities of interest, different communities of knowledge, and that it could turn out to militate against an ability to work together. And you know, the thing is, you get both things out of the same technological evolution. You get the good stuff and you get the bad stuff. And it's, Katina, is there a way to only get the good stuff?
Oh, that's the $1 million question. But I think the mentality of build and they will come, or the Industrial Revolution, mass market, changing. And we're seeing this fracturing. I was involved in a private, closed door, and I can talk about it publicly, but I can't talk about the contents, but it was the 2030, how do we reduce the splintering that's happening, the fracturing? How can government still keep their control over the populace? And it was a comparative study, 2030, between Australia and Singapore. And so they started to list individuals in types and communities in types, but actually we are now building for communities. These apps are not going to work for everybody, but how do we bring people together? Going back to Toby's comment, it's all about trust. I heard trust as well, a recurring theme. If we don't trust each other, then the social fabric that holds society together starts to unthread. It starts to become like loose pieces of thread and string. So I think that's what we all have to work together, this shared view. What are the shared values that we have? Perhaps we all have different values, but what are those shared values where we build and co-design together? That's a lot of the work of Roba Abbas at the University of Wollongong, looking at this co-design as well, Kevin, with your supply chain work. It's exactly the same. I don't know if you wanted to say something, Kevin, on that, just before we're getting so short of time at the moment. But Kevin, did you want to talk about that aspect in the supply chain and trust in the supply chain?
Well, I'll just say very briefly that a lot of, in the supply chain realm, a lot of hope is thrown at things like blockchain, right? Which are technologies to increase traceability, visibility. But supply chains, visibility is necessary for a relationship, right? But doesn't take the place of a relationship. So no matter how much technological capacity supply networks add to increase traceability, there's still the human constraint that you need if you want to develop a relationship within your, if you want to collaborate in your supply chain, or you want to persuade one of your suppliers to do something different, then you have to have a relationship. And so technology can help that, but it can't substitute for that.
And that's the amazing thing with all this connectivity. We'd think that the connections were close and knit. And I think you talk about the humans. It's all about the humans. The School for the Future of Innovation in Society always talks, it's about the person, right? The human being. And all of us have this recurring theme. So Elisa, I think, going back to your comment, I think that's what I want us to take away. Trust about human relationships, of course with machines, of course with apps, of course with our government entities and stakeholders. But going back to, while we have this hyperconnectivity, is it bringing us closer together, or it's sort of fracturing us even more? I think that's a very interesting concept to study.
It is. There's one other thing that I just want to touch on before we close up shop for today, which is that in the busy chart that I showed, I want to go back to that for a second. The way we build trust and the way we build relationships and how that's connected to the technological or other means that we use, and technology is a broad term. It's not just the things that we're using, it's how they get developed and how they, who owns them, who's it, right? So all of us are talking about things like that in a different way, but let's go back to masks, which are very simple. Masks that are federally created and sent out by the Postal Service versus things that are made by 1 million people around the country. They're very different in terms of the social experience of those, in terms of the kind of social benefits that can go along with them. I'm not saying which one's better or worse. I'm just saying that they're different. And the same is true with testing. The same is true with modeling. The same is true with like a number of the things we've been talking about with the COVID safe app you were talking about, Kat. was a terrific example of that, right? The government alone versus partnership and all of the complexity in that. And that kind of stuff, I think, is what I think we just scraped the surface of those issues, but they're really critical. They're critical for how we deal with the pandemic from here to however long it lasts, and for so many other issues. I'm going to close us out, Pat. Thank you, everybody, for participating today.
Well, we all want to thank you, Elisa Graffy. I know it's very hard to bring together people during these busy times. Everyone's scrambling for time, but you've brought together an eclectic panel. Kevin Dooley, thank you so much. Bob Cook-Deegan, Anna Muldoon, and Elisa, yourself, and I even thank myself for speaking, but all our participants. I'm having great joy in seeing this public interest technology colloquium being seen even after the event. So there are now people in the hundreds that are seeing these videos from the public interest tech colloquium. I thank also our logistics team, Cindy Dick and Melissa Waite, who always are so precise, and our new followers, Edmund Dong, and also our existing ones, Elma Hayrick and Toby Shurif. We want to thank you and hopefully see you again in 2 weeks' time. Thanks, everyone.
Thank you, everyone.